Welcome to aminacademy.com. In fluid mechanics, let us discuss about Euler's equation of fluid motion and we'll derive the formula for that. This is the equation of motion in which the forces due to gravity and pressure are taken in consideration. This is derived by considering the motion of fluid element along the streamline as. Here, consider this a fluid element having cross-sectional area delta A and length delta ds. Now, the forces acting on the cylindrical elements are pressure force is here. From here, pressure force is PdA in the PdA in this direction, and from that opposite direction is P plus dou P by dou S into ds with dA. Here this act in this direction, and third one is weight of the element acting downward. Here weight of the element is rho g dA ds. Now let theta is the angle between the direction of the flow and the line of action of the weight of element. That means here this weight element is here, and this is the axis of that element. In between is the theta angle is there. The resultant force of the fluid element in the direction of S must be equal to the mass of fluid element and acceleration. Here this resultant force of this among these forces is first rho dA minus, because it's opposite direction, then P plus dou P by dou S into ds into dA minus weight of that element is rho g dA ds. Here it is acting downward. This force is along this direction is with cos theta. Which is equal to mass into acceleration. Mass of that fluid element is rho dA ds into as. Acceleration through this direction. Now, where as is equal dv by dt and v is the function of s and t. Now I can say as is dv by dt is expressed like dou v, partial derivative of v with respect to dou s, into ds by dt plus dou v by dou t. Further, it is equal, here ds by dt is v, therefore you can write v dou v by dou s plus dou v by dou t. If the flow is steady, then you can say dou v by dou t equal to 0. Therefore you can write as equal, that this becomes 0 now. Therefore as equal v dou v by dou s. Substituting this in 1, suppose let it be, this is equation 1. Now we have Substituting and simplifying, we'll get minus dou p by dou s into ds dA minus rho g dA ds cos theta equal rho dA ds into v dou v by dou s. Now dividing throughout rho ds dA and simplifying, we'll get minus dou p by dou s now after that simplifying, we'll get plus here dou p by dou s rho dou s plus g cos theta, because we are dividing throughout rho ds dA, then it becomes g cos theta. This side after simplifying it becomes plus here, then v dou v by dou s equal to 0. Now here look at this cos theta, we have this is ds dz, this ds. Here cos theta we can say dz by ds, then we'll apply that cos theta here, dou p by rho ds rho dou s plus g cos theta is dz by ds plus v dou v by dou s equal to 0. Then here by simplifying, that is consider dou s and here dou s equal to ds, then we can say which gives 1 by rho dou p by dou s plus g dz by ds plus v dou v by dou s equal 0. Then throughout multiply by ds or dou s, both are equal here. Then we can say we have 1 by rho that is, we can say dou p by rho plus g dz plus v dv equal 0. This is known as Euler's equation for fluid flow in steady condition. We have done. Please subscribe our YouTube channel.